Welcome back. We're in Giancoli Ch2 Problem number 7. A person jogs 8 complete laps around a quarter-mile track in a total time of 12.5 minutes. Calculate the average speed, and B, the average velocity. All right, cool. Well, I'm going to start making a picture here, drawing a picture for the slightly more complex ones. Some of the ones before were a little bit more on the simple side. That's supposed to be a symmetric oval track. You can use your imagination to make sure that it is. We're going to say, let's say he starts there, because why not? And let's say he's going to run this way around the track, start. And so he goes around, he does it 8 times, so that's really the start and the end, and goes around 8 times. All right, we have the total time here. Okay, great. So we need to find the average speed. So average speed is a big question mark. And we don't know the average velocity. That's a question mark as well. So let's start writing down things that might be useful. Hey, speed, I know, is some sort of distance over time. And conversely, or separately I should say, that velocity is my displacement per time. And I'm going to write displacement as my change in x per t, or let me just write in variable sense, v is the change in position over time there. And what's the difference between instantaneous and average? Well, average is over some big interval, so this is actually the average velocity there. And this is over some big distance there, so that's actually some, and over some big time interval there. And so it's actually an average speed there as well. Well, let's figure out his distance. I bet you can do that in your head. You know that he goes around 8 times. It's a quarter-mile track, so 8 times 1/4 there. And now I have 8 quarters, and we know that that's going to be 2 miles. 8 divided by 4. Great, so he's going 2 miles, and we know that that's going to be the distance that he travels. If I drove a car around that, the odometer would go up by 2 miles. And so his distance here is going to be 2 miles, and we already know the time is 12.5 minutes. And so then we go and do 2 divided by 12.5, and we get 0.16 miles per minute, which is a weird unit there. And we'll take care of that in a second. The velocity is our displacement per time, our change in position. Well, hold on. What is this change in position? Well, you said it starts there, but he also ends there because he does 8 complete laps. Okay, well now if I go and measure his position, his starting position, oh, sorry, let me write it like that. His starting position, x, you could say xi, some people say, would be, let's say that's the 0. And if I go and measure this track around here, and I put different positions all along here, right, I would be getting bigger and bigger and bigger and bigger and bigger, but by the time I get up here, it would be right back to what I labeled the start as, at 0, so his final position would be 0 as well. Or another way to label these is his position at time 0 happened to be 0 in this case, and his position at some other time, at the end time, is 0 in this case as well. This is actually the preferred method and preferred format here. You'll see that in math class there as well. Now, if we go and look at the change in its position, well, that's just the ending bit minus the beginning bit, or the final minus the initial, however you'd like to say that in your head. And in this case, it's just the end he was at the 0 mark on that track there, and at the beginning, he was at the 0 mark as well. Overall, you might say he didn't really go anywhere. He traveled a bunch, he sweated a bunch, but he didn't really go anywhere because he ended where he began. His displacement, or his change in position, where he is relative on the earth there, you might say, is a total distance, or total displacement of 0 miles. We're in miles here. So that means that this is 0 over 12.5 minutes, and guess what? 0 divided by anything is just... No, it's not undefined. It is 0. And so it's 0 miles per minute. And this is average velocity. Now, the question is, can we convert that to miles per minute to meters per second? And that's somewhat of a trivial task. We can go and do that. That is not necessarily the focus of this course, just so you know. But let's go and do that, make sure that we can do that at least one time here. It's pretty easy for this one over here. I can go do that one already at 0 meters per second. Boom, that was easy. Didn't even have to do any math for that. Miles per every 1 minute. And so now I need to get in meters per second. I'm going to take care of the minutes first there. So I know how many minutes are in a second, or the other way around. I know how many seconds are in 1 minute. That's nice. So now my minutes cancel out there, and I'm in miles per second. And from the previous question, I know how many meters are in 1 mile, because I went and looked it up. So I looked at a mile, and I can figure out how many meters are in there. It's 1,609.34. It's not a super nice number because these are two different styles of units. A standard, you might say British unit, versus an imperial unit here, the standard international unit there. Metric unit. So when I go and look at that, the miles cancel out. I should probably show that cancellation there. Miles cancel out, and we're in meters per second there. And so now I just need to grab my calculator and do all that bit. That's multiplying the numerators all together, and then divided by all the denominators multiplied together, and we only have one denominator there. Make sure you're using order of operations on your calculator, as a lot of people forget about that when they're punching things into their calculator. We get 4.29 meters per second. And that's it. Oh, sorry, I should probably put this in average speed. Equals speed, average speed, or maybe I'll just write it over here where I kept it nice and organized, 4.29 meters per second. There we go. Excellent, we're done. Well done. Have a nice day.